This video covers the solution for A9. It also covers the notion of using unit testing, and will take a top-down approach in its design. A9 takes a list of positive integers and finds the maximum value. Users input as many integers as they wish. Entering a 0 announces to the program that the user is done entering data. So if we're going to take a top-down approach, probably the first thing that we want to type in is main. Let's go ahead and execute main and see what it does. It comes back and it says name error. Name main is not defined. And the reason that it's saying that, of course, for many of you, you realize, we never defined a function called main. So we're going to go ahead and first of all comment this, execute program. And up here, I'm going to make another comment. This is the main entry point for the program. Doesn't require any arguments or anything along those lines. So let's go ahead and type in main. Whoops, got to do define first. DEF, define function main. And put in a colon. And now what it's going to want to do is accept input for all of the elements of main. We are obviously going to need to get input. So let's go ahead and just write a comment for the input phase. And we're going to want to process this. I'll just put in a third hash mark. We're going to want to process this. And then we're going to want to output everything, right? One of the things that ultimately becomes very, very beneficial is unit testing. Unit testing is the process of using a function or creating a function whose sole purpose is to test other functions. For example, if we have a function that's going to be accepting a whole bunch of user input, let's say 200 names and addresses, and we want to test that function fully, it is very, very inconvenient to sit there and input 200 names and addresses into the computer just so that we can make sure the function is working. And if the function fails, then we have to do that all over again. With a unit test function, we simply create input of those 200 names and addresses so that they're already there. And we simply test the function using that information that we already created. Perhaps it was stuck into an array, perhaps it was stuck into variables. The key is we set the stage so that the function under test will be able to actually work. And if it fails, then we know we can go in there, make a change, and very quickly go back and test it. So the way that we implement a unit test is we go to our main and we create a function. And I'm just going to call my function unit test. And as you can see, it is not unlike any other function. Main will execute, it will come down here and it will run into unit test, and then it's going to go to a place called unit test and try to execute it. So I'm going to go ahead and come up here and I'm going to create a place and I'm going to call it a new function, DEF unit test. And what this is going to do, as I said, is it's going to call all the other functions as I create them. Right now, though, we have a tiny challenge, and that is, what functions am I going to write? What functions do I want to put into unit test? Well, before we can figure that out, we need to start tinkering around with our program, again, using the top-down approach. Clearly, what I want to do is input some information. Ultimately, that information is going to be stored in an array. So while I am at it, I'll just go up here and I will create myself a variable to hold my data. And let's see, I'll just call it int_array because I just can't think of anything else. You could call it data in or whatever. And I will define it as int array, and int array holds user input. Down here in my input phase then, what I'm going to do is int array is going to be equal to get user data. The problem is we haven't written a function called get user data. So once again, I'm going to come up here again. I'm going to go def get user data. And that'll be good enough. That'll be good enough. Okay. So what's involved in getting our user data? Well, to get the user data, first of all, I want to define another array, and I'll just call this A is equal to an array. And as soon as I define it, I will return it. Return A. So now I won't generate any kind of an error in my program. Get user data exists. It's just that it doesn't return anything. It basically returns an empty array. So how am I going to populate the information in that array? Well, I'll use a while loop. And if I'm going to use a while loop, I'm probably going to use a flag of some kind so that I know what the end of the loop is. And I find that using done for a flag makes the code quite readable. So I will go ahead and say done is equal to false. And I will use a while loop to gather my input. WHILE, not done. And I could, at this point, write all of the code for gathering an integer or obtaining an integer from the user. But there's a cardinal rule about functions, and that is we want to do as little as we can in each function. In other words, a function has a clear, definable job. This function's job is to get user data. This function's job is not to get integers, per se. So I'm going to write another function to get integers that will be called from this function. So what I'll do is I'll say value is equal to getInt. And I'm going to want to send some kind of a prompt to the user, so I'll go prompt. And now I'm in a loop that'll allow that to happen. I need to make a test, right? If val is equal to 0, then done equals true. However, if it's not equal to 0, then I want to go ahead and append whatever value is onto the array. Okay, so that's pretty straightforward, as you can see. However, I do have a little bit of a challenge. First of all, I haven't defined getInt, and secondly, I haven't defined what the prompt is. And I think what I want to do is I want to kind of make a custom cool prompt. And the prompt is going to indicate the number of integers that have already been entered, or whichever number you're on with entering. So I'm going to go counter. Count is equal to 1. And then here I'm going to say prompt is equal to quote integer number. I will actually pop in a space there so that it looks nice. String count, just like that. I'll go ahead and concatenate a colon space on the end of all of that. Okay, so now we've defined what prompt is. But we still can't run this because we don't have getInt. So again, we're using the top-down approach. Remember, we went from the top of main into get user data, which is where we are right now. And now we're going to do get integer. Okay, so let's go ahead and define get integer, and it's going to accept a prompt. and I'll just call it P for right now. And I'll come down here and I'll say int in is equal to 0. And it occurs to me that I've already written something similar to this. Let's go back to A8, get float. Now the thing that's really cool about copying this is it also has remarks on it already. So I'm going to copy that. I'm going to come over here to my program. I'm actually going to replace that with all of this. This function obtains, it should say an integer input from the user that is greater than 0, just like so. On error, the user is prompted to try again. So the parameter prompt, which is this critter right there, is a prompt to the user so that they know what to input. And it's going to return a successful integer value. So now I'm going to come down here and I'm going to change this to get int. And actually I'm going to call it positive int. Get positive int. And then down here, I am going to adjust this big time. Okay. So we'll get rid of that comment because it's not going to make sense. And I'm going to say done equals false. I'm going to say count equals 1 because I remember having to do that. Here I'm going to say while not. Here I'm going to say int in is going to be equal to, and do you remember the try catch block that I had in an earlier video? I'm just going to take advantage of this. Okay, so try to turn it into an integer. So we'll come over here, int is going to be equal to int. Actually, this should be int in string. Alrighty, so we're going to turn it into an int. If it's successful, we're going to set done equal to true. If it's not successful, have a message, integer cast failed. I was expecting a positive integer. Please try again. Now, you'll notice for some of you guys who've been looking at this code have probably realized that, well, wait a minute, Dave, you handled integers, but you did not handle anything that was positive. Okay, so I'm going to come down here and fix that. And the way that I'm going to fix that, because we did the cast right there, I'll put in an if statement. If int in is greater than 0, then all of this stuff happens. Does that make sense to everybody, I hope? So now I've made it a positive integer input. Done is true. Life is great in River City. We can get the nastygram if it fails. All right, so done is equal to true. And really, all I have to do is go down to the end of this right there and say return int in. The problem is int in really needs to be defined, right? So we'll just come here. We'll come up here at the very top of this, and I'm going to go int in, and I'm going to set it equal to 0. So int in is defined, count is done. Now all we have to do is, actually I didn't want count here because I'm just simply getting a positive integer, so that's not necessary. Sorry guys. So there we are. I think we have it covered, but you know what? I don't really know if this is going to work or not. So finally we're at a point to where we can check out our function using our handy dandy unit test. Here, I'm just going to take a minute and comment this out so it doesn't get in my way. And up here, under unit test, I will go in here and set the prompt. Prompt equals quote integer. And you'll notice if we go to main, it's going to go to unit test. It'll do this stuff here, but it isn't going to do anything else. So here I am checking out only one function. I'm setting the stage to test the function by giving a prompt. And now all I have to do is print the result. Now it's a really good idea that when you're doing something like this that you include labels. So I'm going to say get we'll put some quotes around that. Function. And integer equals value equals. I have a closing quote, and I need to go ahead and say whatever the positive integer is, and I never defined it, so I'll just say my int is equal to that. And here, we'll get rid of that extra space because I'm going to use a comma for my output. My. All right. We'll try it out and see if it runs. See, it went straight to enter an integer. That's a good sign. So I'm going to do this. This is garbage. Hit enter. It says I was expecting a positive integer. So this reminds me, or I read that, so this clues me in that I need to change this message. So since I'm here, I'll do that right now. Enter a positive integer. So I'm following my own little set of rules. Enter an integer. Let's try a floating point number, 1.5. Nope, I was expecting a positive integer. So now it's time to enter an integer, and I will say 8. And it says function get positive integer, value equals 8, program finished with exit code 0. Our unit test on my int get positive int right here, my unit test on that function worked like a champ. So I'm a very happy camper. Now that we've done that, we're ready to actually test our user data. So what I'm going to do is I'm going to come over to here and I'll just comment out the unit test stuff that I've done so far. And I'm only commenting this out because who knows, I may need to go back and test that information all over again or test that function all over again. So now my unit test is going to call get user data. We'll come down here. Get user data. And I need, of course, a place to store that user data. So I'll just say A equals this empty array. And then here, I'm going to go A equals get user data. And then once again, I'm going to print the results. Except for I didn't want it here. I wanted it in my unit test. So let's just grab all of this. Cut it out of here. And place it here. Okay. So I want to print it. Function will be that. Value equals A. There we are. We're ready to go ahead and run the next phase of the unit test. So run the program. and it totally crashed. And it comes down here, it says value equals getInt prompt, name error. Name getInt is not defined. Well, that's not good. So if we blip up to get user data, because that's obviously where the error is at, I notice it down here, getInt should be get positive int, like so. So let's run it again, and let's see what it does. Enter integer number 1. So I know that it's going to process my integers just fine. So what I want to do is, actually I'll just put in a -3 and see what it does. It just said get integer number 1 without an error message, which I don't want it to do that. So let's come back here to this, because I obviously missed this from before. Let's put in an else. Print POSITIVE integers only, please. And that solves that. A little bit of housekeeping. So we'll come back here and run it. And I'll just say -1. Positive integers only, please. So I'll just go 8, 7. And that's looking pretty good. Then I hit enter, or 0, and hit enter. And it comes back and it says positive integers only, please. I have a problem, don't I? So it doesn't look like I did a very good job unit testing my get positive int function. So I'm going to say greater than -1, like so. So let's go ahead and stop this and run it again. I'll say -1. Sure enough, that's working. This. I'll even throw some junk. And it's always saying enter integer number 1. So I see a problem right there as well. So let's go ahead and just put in a 0 and see if it does that correctly. And it did. It processed the 0 correctly, but my integer number isn't updating. So if we come down here and we see the try catch, we come down here, try, we convert it. If it succeeds, right? If it succeeds, then we can go ahead and update the counter. So I think what I will do is, I don't have a counter here, huh? Oops, I'm in the wrong place. Sorry, guys. We come down here, value done equals true, else update the counter, count plus equals 1, and then append it, and we'll run our test again. Integer number 1. We know that the rest of it works, so I'll just put that in there. Sure enough, it's doing my count correctly now, and I put in 0, and sure enough, the array output is what we want. So you'll notice that what I have done here is I have started working my way through the functions that need to be created. I threw them into the unit test, and I tested them, and I made sure that those functions work perfectly before I move on to the next function. And if it wasn't for the unit test, this thing might be just a little bit more difficult. Grant you, in this case, because this is a simpler program, it's not going to be that much more difficult, because we could, in truth, do it all in the main. But when you get into really, really complicated programs, they're going to ask you to do unit tests on each of your functions or on particular modules or something along those lines. So it's a really good idea to know how all of this works. Okay? So, oh yeah, another point I wanted to make. This unit test business that you see will be on the final exam. I will be asking you to create a unit test function. Okay, now that I've done that much of it, I know that I have my array input. I'm good to go. So the next thing to do is go ahead and process my array for the maximum value. Remember I said before in our unit test, we're going to use test data to make it a little bit easier to check functions. One of the functions that we're going to need to be able to check is our max value function, which we're going to be writing next. But before we can test it, we have to have some data to use. Okay, so there are a couple of ways of handling this. One way is we can just simply create the data outright, or we can write a function that will do it for us. The advantage of writing a function that will do it for us is that if we decide to get fancy and use random numbers or whatever, we can go ahead and do that. For right now, though, I'm just going to make it really easy on myself. I'm going to go DEF for define function, and I'm going to go populate test data. And it's going to be really easy. All it's going to do is return an array of data. And that array is going to be 1, 9, 2, 8, 3, 7, 4, 6, 5. And that's all I want. Obviously, the max value here is 9. And I have lots and lots of different values that are in here. So I should be good to go. Now, in my unit test, what I will do here, A is defined in that particular spot up there, but I'll go ahead and comment it out. And I think what I'll do just for readability is I will add a space. And here I'm going to say A is equal to populate test data, just like that. And now I'm going to say max val is equal to get max val. And I'm going to pass it A for my array. Okay, but I haven't written my function yet, so let's just go ahead and grab this. We'll copy it. Let's get rid of that extra line. It's looking kind of clunky. Define another function. And there it is. It's expecting a parameter A. Remember, you guys, you must comment your functions. Just like I did here. This function obtains an integer. I talk about what the prompt parameter does. I talk about how it returns information. So each one of your functions needs this set of comments on it. Okay, so there's the max val. All we have to do now is write our max val function, right? So I'll use for I in range. I don't know what the length of my array is, so I'll just go length, len, a. This is allowable in this class. Returns back the length of the array. It's the only way we can figure out what the length of an array is that I can think of offhand. So then, I can say before I begin, max is equal to a sub 0. In this loop, I'll say if a sub I is greater than max, then max equals a sub I. When we're done, return max. And once again, we'll do a unit test on it. Come down here, there it is. We're going to get the value, and we will print the result. We know that it's supposed to be 9. This is already commented out. And you'll notice now, because I've done it the way that I've done it, if you will, it'll just run and give me a result. Value equals 9. That is exactly what I wanted. And if I'm in doubt, I can come back here and I can change this to, say, 31. And run it again. Value equals 31. So the max value routine is doing exactly what I wanted it to do. Okay? So we popped it in the unit test. We are good to go. The only thing that remains in all of this is to do our output. And I'm not sure that it's worth the trouble to do output. So what I'm going to do now is I'll do pound there, or comment out that, because I've completed that unit testing. Sometimes you can just go ahead and just call the unit test itself, although I'm not sure that's really the wisest thing to do, but you can go through and call the unit test if you're asked to do that, okay? I'm not going to do it though. I initialize the array. Here, I gather my user data here in my process, because the process is working. I can go ahead and literally do this, declare it equals 0. In fact I think what I'll do is comment out unit test. I don't need to do that anymore. I'll come over here and my int array right here. Declare variables. There's that critter. Max val. There's that. And then finally, I'm ready to write my output function.